Long ago, before cars or even trains, people needed to cross rivers and valleys. Suspension bridges with roadways hung from strong cables provided a solution. Early versions used ropes or vines like the ones built by the Inca people in South America. One of the first engineers to bring suspension bridges to the wider world was James Finley. In the late 1700s and early 1800s, he built many bridges in the young United States, helping people travel and transport goods. These early bridges used iron chains for cables, a big step up in strength. However, it was in the mid-1800s that suspension bridges truly took a leap forward. John Roebling, a German-born engineer, used strong steel cables and innovative designs to build bridges that were longer and stronger than ever before. His masterpiece, the Brooklyn Bridge, opened in 1883 and became a symbol of what suspension bridges could achieve. It showed the world that these bridges could be both beautiful and incredibly strong, ushering in a new era of bridge building. Suspension bridges might seem magical, but they rely on the amazing properties of specific materials. Steel, a strong and flexible metal made from iron and carbon, is the heart of these bridges. Steel cables, made of many thin wires twisted together, provide the tensile strength to hold up the bridge deck. Think of them as super strong ropes. These cables are anchored to massive concrete blocks called anchorages at each end of the bridge. The towers that support the cables are also made of steel. These towers need to be incredibly strong to withstand the enormous weight of the bridge and the forces of wind and traffic. Concrete, a mixture of cement, water, and aggregates like sand and gravel, is another essential material. It's used to build the anchorages, tower foundations, and often the bridge deck itself. Concrete is exceptionally strong under compression, meaning it can resist being squeezed or pushed. Building a suspension bridge is like putting together a giant puzzle, one requiring careful planning and many steps. First, engineers carefully choose the bridge location, studying the landscape and the ground conditions. Then, the massive anchorages are built on each side of the river or valley. These anchorages are like giant weights holding the cables firmly in place. Next comes the construction of the towers. These towering structures are built section by section, piece by piece. Once the towers are complete, it's time to string the cables. This delicate operation involves pulling heavy steel cables across the span high above the water or ground below. With the cables in place, vertical suspender cables are hung from them. Finally, the bridge deck, which carries the roadway, is attached to the suspender cables. The deck is built in sections, gradually extending from each tower until it meets in the middle, completing the bridge's majestic span. Suspension bridges are more than just structures. They often become iconic landmarks. The Golden Gate Bridge, with its distinctive orange color, is instantly recognizable as a symbol of San Francisco. Completed in 1937, it was the longest suspension bridge span in the world at the time. Another engineering marvel is the Akashi Kaikyo Bridge in Japan. Finished in 1998, it boasts the longest central span of any suspension bridge globally, stretching an incredible 1.24 miles. These bridges are testaments to human ingenuity and the incredible things we can achieve with engineering.